Hello and welcome to podcast series Voices of Innovation Shaping the Future of Tech Education. I am your host Dr. Neha Bansal. Today's topic of discussion is transforming classical physics to quantum physics. And for this discussion, we have a very distinguished guest with us, Dr. Rahul Thakur, working as assistant professor in the Department of Computer Science and Engineering, IILM University, Gurgaon. Dr. Rahul has obtained his degree in PhD from BITS Pilani and he has a decade of experience in the field of physics and cosmology. Dr. Rahul has published many papers in the field of physics in very reputed journals. So with this his expertise and rich experience in the field of quantum physics, we are delighted to have him in this episode. So I welcome you, Dr. Rahul. Dr. Rahul, as this quantum physics topic is very new in the market, so let me start. Can you explain me what is classical physics in simple terms and how there is a need to transform from classical physics to quantum physics?
Thank you, Dr. Neha, for the introduction. So, physics is all about to study about the law of nature, like how gravity works, what are the fundamental forces, and what is their significance and all. So, coming to the classical physics, so classical physics is a branch of physics which can be explained by the help of Newton's law of motions. Although there are some experiments like black body radiations, photoelectric effect, like if you follow light on any metallic surface at a certain frequency, how electron is ejected from that. So these are the some experiments where classical physics completely fail to explain those phenomena. So we can say these are the turning points or motivation behind to study or go to the quantum mechanics from classical to quantum.
So, very well said, sir. And I think now the term of quantum physics clear to us and to our audience. My next question is: as we are in a digital era and we need these fast computers and all, so why quantum physics is needful than the classical physics?
Okay, so basically classical mechanics or classical physics in a one time or at a one time we can study about one state only. For example, if you can switch on the light at a time or you can switch off the light. So only one thing you can do at a one. So same in the same manner classical bit is working. Either it will come to zero state or it will come to one state. So, but quantum mechanics gives you the flexibility. The superposition principle of the quantum mechanics gives me the flexibility to study the both the state together. Like at the same time we can study the state 0 as well as state 1. So basically it works in a it makes a superposition, so it's work in a linear we can write it in linear terms like alpha into ket0 mathematically, alpha into ket0 plus beta into ket1. So this gives me the flexibility to study the many possibility at once. So basically the quantum computers works on the same principle. At the same time it can process a many information. So this is the benefit over classical to quantum computing.
So, with this, sir, I think quantum computers are very needful and become powerful with this era. So, my next question is, since the quantum term itself is very complex and I myself find it very complex, so can you tell me what are the foundation skills that a student might be needed before starting to read or study about the quantum physics?
Okay. So before going to the quantum physics or quantum computing, so first skill is strong mathematical background should be there. So like namely linear algebra. So linear algebra plays a very important role when it comes to the quantum mechanics or quantum computing. So you will find linear algebra is sitting everywhere in the quantum computing. So my suggestion for undergrad student is they have to focus on their during their foundation area in the matrices, vector spaces, basis, and all these concepts because they are going to see their direct application in the quantum mechanics or quantum computing.
So, as you are taking two terms, quantum physics and quantum computing, so do these both terms are same or there is some difference, and how quantum computing is related to quantum physics?
Okay, so basically quantum physics is all about to study about the electrons. How, like if we talk about in terms of classical mechanics or classical physics, so we can see here phone is here, the inductor is here, you are having a remote in your hand. But if I will ask you the electron is moving here, so one cannot see the electron motion and all. To study on a very small level or that this is the main reason to switch from classical to quantum. And coming to the quantum computing is, so basically like earlier I said it deals with the superposition state. So in classical computing only one state is possible at a one time, like you can pass a bit classical bit 0, either 0 or either 1. But in a quantum bit you can pass the both the information or many information together. So this thing makes the quantum things more clear, and the precision level will be very high.
So it means, sir, I can say that quantum physics and quantum computing both are the two phases of a single coin. I can say that from the
Yeah, we
statement.
can see.
Okay. So my next question is, what are the career opportunities for the students in the field of quantum computing, and how they can start with it?
So quantum is a very growing stage nowadays. So there are a lot of opportunities for the student. They can start their career as a quantum hardware scientist or quantum software scientist. Apart from this, they can make their career in the higher education. They can go for the research in the quantum levels or quantum computing and all. Many of the universities are offering the PhD degree, so they can build their career in academia as well. And there are other applications in the field of medicals and medicine sciences and all. And other application is student can start their own startup as well, and they can start there to building the quantum software or the quantum hardware things. So this could be one possibility also for the undergraduate students.
So, very well said, sir. There are many career opportunities, as you said, in the field of quantum physics. So, thank you so much, Dr. Rahul, for sharing your thoughts and insightful in the topic of transitioning from conventional to quantum computing. So, I think it will be very useful for the students, and they can start a career in this. So with this, I am Dr. Neha Bansal signing off from today's series of podcast. Thank you so much.